I will be mostly talking about the potential of large client data sets and client-related data, and how we could apply machine learning approach to maximize the value of this data for the businesses. And I mostly will be talking about B2C businesses. So we will focus the really more or less big client databases and or any client related information, because as we know, currently business really is trying to collect the data but not always know what to do with it. And today I will focus not only on the technical approaches or data science or machine learning algorithms, maybe slightly, but mostly I will talk about the data value and how exactly the business could benefit from the client and customer data sets and customer related data, and machine learning models specifically, and data science in general. And closer to the end of my today's speech, I will also talk about how we can apply the more complex approach, where we use both data science, machine learning, and state-of-the-art large language models in a combination to gain maximum from the customer-related data. And let's start from the ancient times, and thanks to generative AI, who built this who generated this beautiful picture for me. I have to be honest with you. I believe that humanity make data-driven decisions since its childhood, when the humanity were mostly in the caves and in the forests, but not in our modern way, where we use well-structured data in Excel. But the data sets at these ancient times were the millions of years of our evolution. So we collect the data and use the experience to survive. And it's like, for me, it's clear that the nature is really a very smart machine, and we basically are here because we make data-driven decisions based on experience. But jokes aside, actually, what does it really mean to make a data-driven decision? Because before businesses started to collect the data, customer-related data, or any other type of data in general, and before business were trying to analyze this data, all the decisions were made using general knowledges and intuitions, and actually pretty scattered part of data that still was possible to collect. Currently, when we are talking about data-driven decision making, we tell that it means that we do have enough data, so we can build the cause-effect relationship between data and our decision, obviously. And the benefits of this approach are pretty evident, but still I should mention some of them. And really, it makes our business more transparent, both for our customers and for us as the businesses, because it's like we understand which number or which complex of numbers made us to make one or another decision. On the other hand, data helps us to improve our processes continuously, because world is always changing. World is not a really stable place. It's fluent, and our data is fluent. Data is fluent too, fluidic, and that is why we change the data. If the world is changing, the data is already changed, and we have to improve gradually and iteratively, and data helps us to make these decisions. And it's data-driven decisions could definitely reduce the cost and improve revenues by optimizing different processes, but optimizing our marketing campaigns, by reducing operational costs. That is pretty obvious too. And when we really have good data about our customers, we also can better understand the market itself and the market trends. So when I'm talking about clients' data or customers' data, what I am really talking about, and why it is valuable for business in general. Let's divide different client data sets and client data into several different types, because it may help us in future to better understand different data sets and machine learning approach I will talk about. So the first cluster of data is demographic data. This is it's like pretty obvious, but still it is age, it is gender, it is a location, it is an income level, it is an education level, it is an occupation, it is marital status, it is a number of family members, and we can go on and go on. And the data availability, of course, depends on the ability of business to collect this data first, and of course on the data privacy and laws, but still sometimes we really can have this data, and it could be really beneficial for us. It is behavioral data. So for example, for the retail, it could be the purchase history, browsing history, and different engagement data. It could be messages, it could be emails, depend on the exact situation. It is also product usage data. It's interaction between customer and support. It's amount of purchases, it's a frequency of purchases, etc. Also, sometimes psychographic data could be really useful for us and for businesses. It's a personal interest, it's a lifestyle, it's values and attitudes, it's personality traits. If available, of course, it's not always the case. Opinions and preferences, and this could be really useful. And also the customer feedback data, survey responses, reviews and ratings, social media comments, support ticket data. And when we are talking about the data, which could be available for one or another business, let's start from e-commerce and retail data. So common customer data set in e-commerce mostly include demographic data, behavioral data, and probably feedbacks on the products, on the services. Let's have a look at the example. Here, I took a woman's e-commerce clothing reviews dataset. It's a public dataset, but I believe that and also on my personal experience, it's a pretty common data that fashion retail could have. And what we have here, it's an age, it's a title of the review, it's a review text on the product itself. It's a rating of that person proposed for this product, and it's also the different types and classes of the clothing itself. And let's have also a look at the typical data that financial services could have about their customers. It's also demographic data. It's a behavioral data, but with a strong focus on transactions data. And it also could be a feedback data if we are talking about B2C segment of the banks or another financial services. For example, here I also took a publicly available data set, which could be potentially used in machine learning already. And what we have here, it's a product type, it's a sub-product type, it's an issue with this product reported by the customer, and it's also a sub-issue. And as I remember, if I remember well, it also this data set also includes a lot of another useful information about the customer feedbacks. And as a summarizing the previous information, basically it's pretty straightforward. If we have customers demographical data and some behavioral data, we already using only the intuition itself and basic analytical tools like spreadsheets, Power BI or any another tool, we can already have some insights into the data and even build our strategy based on it. However, if we apply something more sophisticated like machine learning algorithms and even artificial intelligence, we could have so much more than just an analytics. Let's go into explaining basic definitions here, because I believe currently, like, everyone really can understand what is the artificial intelligence and machine learning and the deep learning, but it might cause some confusion. So when we are talking about artificial intelligence, it's basically we are talking about something really powerful tool that can generate a text, generate pictures, make predictions, build very, very detailed forecasts. That's okay, and that is the truth. But when we are talking about machine learning, it's just one possible approach to the artificial intelligence. However, again, to tell the truth, machine learning is basically every artificial intelligence tool that we now possess. And if we talk about deep learning, we talk about neural networks. And when we are talking about data science, it is everything, including artificial intelligence, machine learning, and deep learning together, based on the general mathematics, statistics, data visualization, and data exploration. So when further I will be talking about data science, I will automatically be talking about machine learning, sometimes deep learning, and artificial intelligence. So don't be confused, please. And let's talk about when really machine learning and data science can be impactful and can be really beneficial for our business. First, if we have data, it could be structured data, it could be unstructured data, it could be texts, like I told before about client reviews, client feedbacks, etc. It could be numbers, it could be numbers of purchases, it could be amount of purchases, it could be revenues from one or another channel, it could be table data, it could be any data. If you have the data, and if you have enough data, you already can consider data science as and machine learning as a possibility for your business. And it is very important that data has to be meaningful for us. What I mean by that, data has to be representative. So it really at least should cover every group of customers you could have. You could have in future or you have now. It is really important because otherwise any machine learning model built based on this data will be biased and will be not really accurate. And again, data has to be accurate. Data has to be full, or at least it should be full. So we should not have a really huge amount of missing values in our data set. So, for example, we really should have the age and the gender of each customer you have if we are talking about demographic data. Sometimes it is not the big deal if we don't have like a 5% of our gender or age data, but we should try and have as full data set as possible. And another requirement for the machine learning model and for data science to be efficient and more efficient than that just the data analytics. The data should be complex. Data hides secret. If your data hides secrets, if you really cannot deal with your data using just Excel and Power BI and simple business analytical tools, just not enough to get enough insights from your data. You should consider something more sophisticated like machine learning models. And let's talk about the necessary volume of the data that we will need for the machine models to be potentially more efficient than just the common analytical tools. If you have like 300 data records and records about 300 of your customers, you already should be thinking about using machine learning and data science approaches in future. If you have 1,000 records, you should perform a research and understand the capabilities of the machine learning models, because it is a pretty common situations when 1,000 records are already enough to build a pretty good machine learning model. And actually, if you have 10,000 data records, I believe that you are already using a machine learning, and maybe you are not our target audience. But if you do have 10,000 data records and you are not using machine learning, you should. Definitely you should. And what really defines the data value? First and foremost, it's a domain expertise. No one except the business itself and professionals know the data better than actually these professionals. If you understand which data is really which part of the data is really important for you and what to collect, it is already huge advantage. And if you aren't understand why you collect the data and what data you collect, it's highly likely that this data would be not really useful. The second and very, very important aspect is data quality. If your data is not accurate enough, that any machine learning model that is built based on this data will be really bad. So you need to be very careful about data collection process. And this sort, but sometimes it is also important. We really need a huge amount of data to build a good machine learning model for any purpose. And let me tell a few words about different machine learning algorithms. It's not really important for us right now. However, it is like necessary to give some definitions to the audience, so they will follow. They will follow the speech better. So the first and maybe the most important machine learning approach is supervised learning. So we show the machine learning model the correct answers, and the machine learning model can make correct decisions in future on the new data. We also have an unsupervised learning model. When the machine learning model learns the patterns in the data, not on the labeled data, but just on the data itself, to find the necessary and the most interesting, let's say, patterns in this data. Another kind of the machine learning algorithm is reinforcement learning, and we will not cover this topic today at all, but you just it may be good to know that it exists. And also, when people are talking about deep learning, it means that they're talking about neural networks, which are like the most sophisticated machine learning models in general. And let's start with unsupervised learning, which basically means that we are going to divide any data into different clusters in order to use the information about different groups within the data in future. What I mean by that, let's start with the success story where Nike applied sophisticated clustering techniques for marketing personalized companies. This information was found in Forbes, and what they did actually, they utilized advanced analytics and clustering, unsupervised machine learning algorithm, as to find the most meaningful customer segments. After that, they analyzed purchasing behaviors, preferences, and engagement data. They created distinct customer profiles for targeted marketing efforts. And as a result, they were able to increase sales, personalized recommendations led basically to the high conversion rates, enhance customer satisfaction. It is also what their task, and they accomplished it. So customers received relevant product suggestions, improving their shopping experience. And also they improved their marketing. So the targeted campaigns resulted in better resources allocation and higher ROI. And let's now move to more practical example. It's a case study performed on the public data set of the retail company located in Britain. So what basically this data set includes? The information is it's like not really complex. We have a transaction number, we have a date of the transaction, the product indication, product name, the price for the product, the quantity of the product purchased by the customer with a certain customer number, and the country. Here in the table, we see that everyone is located on the United Kingdom, yes, almost all of the customers of this company were located in the United Kingdom, but they also have some segment in Netherlands and France and European Union, but most of them were located in the UK. And the task of this customer segmentation was to improve customer targeting, again, exactly like for the case of Nike. It's an enhanced customer experience, and of course we always want to increase sales and customers loyalty. How it was performed? It was performed by analyzing RFM. What does it mean? RFM analysis quantifies customer value by evaluating their purchasing behavior based on basically only three metrics: recency, how recently a customer made a purchase; frequency, how often they make a purchases; and monetary value, how much they spend. Basically, these values can be easily calculated from the data we saw before using like Excel. So it's pretty fast and easy to do. And I just skip here the process of the machine learning model training itself. Let's switch to the results. By performing the clusterization, so-called k-means clusterization, it was found that customers could be divided into three different groups. We currently, at this slide, we cannot really know what do this cluster really means. So let's just call them cluster 0, cluster 1, and cluster 2. What we can tell for certain is these clusters are really more or less well distinguishable for one from another. Just looking at this picture, which is a simplistic representation of this clustering results. And we perform a simple very simple exploratory analysis for each cluster. So we can find that for the cluster number 0, we observe moderate R, moderate frequency, and moderate monetary. For cluster 1, we see the lowest recency. So almost all of the purchases was performed like not a long time ago. We have a highest frequency, so they purchase frequently, and we have high monetary, so they really spend pretty lot of money in this market. And cluster 2, it's at-risk customers, so they have the highest recency, they purchased long time ago, the lowest frequency, they don't really our loyal customers, let's say, and we have a low monetary value. And if we look at the distributions of recency, frequency, and monetary across these different clusters, we really can easily observe that it's like for all of cluster 2 or at-risk clusters, we see that all of the purchases were performed like were made a long time ago. For our occasional customers, they purchase like more or less frequently, but not so as our loyal customers, and like pretty predictable when we already know everything picture could be observed for the frequency distribution across different clusters. So for the at-risk customers, actually they forgot how to find our shop. for the occasional customers cluster, we see that they from time to time they visit us, but not really. But for the loyal customers, they're here like not every day, but pretty frequently. So that is good news for us. And for the monetary distribution across these three clusters, we can see that at risk customers spend almost nothing, and occasional customers spend something, but not really a lot. And our loyal customers, they spend a lot, which is like as expected. And we also can see the pretty similar picture by observing median values for our three key metrics for R, for F, and for monetary also. So that is pretty obvious. But what is interesting, if we compare the average sales for the average sales for all of our customers for all the data set, we can see that in general, like average customer stops really buying anything from us starting from September, and the sales decay pretty fast. But for our loyal customers, in September they're just starting to buy in our shops. So it is already an interesting observation, and it's a possible point where we can apply targeted marketing for our loyal customers. For example, we could really go deeper and deeper into the insights for this exact particular case, but here I should tell that when we already have the data about the customers' purchases, the customer behavior, it's an easy task to perform a clusterization, and that's okay. And we can see that these clusters, these segments of the customers, they are really meaningful, but it is not, unfortunately, always the case. And sometimes we just have a pretty basic data about our customers. So we could have like 8 different clusters or segments of our customers, and in this case, we really need to go deeper and deeper into each cluster and find the meanings of these clusters, so we can again apply the marketing technique for each of the clusters. But if the job of the machine learning engineer or data scientist, if they did well, that you should consider their opinion. These clusters, these segmentation techniques, these unsupervised learning techniques, they could be really helpful for the decision making. And let's talk about supervised learning approach in the customer's database. So this approach is pretty straightforward. First, we have to label our data, and it's always easy to show this example on cats and dogs. So where we just show on the photo where is cat, where is dog, and after that we train our machine learning model on these pictures, and the machine is already know where is the cat and where is the dog. I know that's like the explanation for children, but it really works like that. And the same works when we are using machine learning for our customer data sets. And let me tell you something about Netflix and their success story. Netflix, they are really good at machine learning, and they started at 2016, and I believe their machine learning algorithms, they are really good, and I can't always say that their content is as good as their recommendational algorithms. In any case, and it is known, they use churn prediction techniques to find the customers who are going to quit the services, and they will they will recommend you they will do everything to make you stay, and it really works, and it works on me. I believe it also can work on other even less loyal customers, and that is well known. Netflix, they are good at applying different machine learning algorithms, especially in supervised learning algorithms. But let's move to the case study. Another publicly available data set. It's a telecom data, the data about their customers, and they also provide this data to the public, so the data scientists could try and predict churn as accurate as possible. And we have different data fields like total days, like total day calls, and basically different time metrics. And from this data set, we can see that almost 15% will quit the service after this certain amount of time passed. And let's again skip the part where we apply machine model, and let's see how accurate these machine learning models are. And I propose you to focus on this F1 score column. It's basically the representation of the accuracy, but slightly more more meaningful. Let's say that it is proportional to the accuracy, but it's not exactly the same thing. What we can see that the best model we trained on this data was able to be pretty accurate in predicting future client quit. So it was like up to 82%, which is okay, which is expectable. And what I can say, it's a pretty common number for the churn prediction task. And I believe I believe and I know that in my experience, telecom companies they really use machine learning to predict when a client is going to quit. So they will be bombing you by the emails, by the phone calls when they feel that something goes wrong. So yes, this approach is working for the telecoms, definitely. And now let me also tell you about how we can apply large language models and client database, and again maximize the value of our data set and of our client reviews and client reviews and client feedbacks. Let me tell you about the capability of large language models, because when we are talking about machine learning, currently we cannot avoid the topic of the large language model of ChatGPT or any another model, because basically everyone uses it now. So what is a large language model? Not even really large, but language model is capable of now. It is capable to perform a sentiment analysis, so we can understand whether the customer feedback is positive, negative, or neutral. And this task it was resolved like a long time ago, but still modern large language models they are really good at this task. It's also, and as an example that I can give you, that's we can identify dissatisfied customers from negative reviews, which is already meaningful information for the future application. So large language models at the context of feedback analysis, they can extract key themes, like identify recurring topics and themes in customers' feedbacks. As an example, we can detect common issues like delivery delays or product quality in reviews, and this also pretty useful information for our client database. It's an entity recognition, so we can extract and categorize entities like product names, like locations, and brands. And as an example, we can highlight frequently mentioned products in customer reviews. And also large language models, they are really good at text classification in our context. So they can categorize the feedback by automatically classifying the feedbacks into predefined categories, like this one goes to support, this goes to product, this goes to service. As an example, we can sort in feedbacks into technical issues, service complaints, and product suggestions, etc. And what we could achieve if we will use the combined strategy. So we use both machine learning and machine learning, like classic machine learning algorithms and large language models. We of course collect the data, we collect the demographic data, and we collect relevant feedback texts. After that, we extract the most important features from this data. But by using LLM, we can perform, as I told before, sentiment analysis, topic modeling, entity recognition, and we can use this category, our new categories, results of the sentiment analysis as our new data fields in our data set. After that, we can integrate this data for the enhanced machine learning models by combining features. We just merge the text derived insights, we train the model, and as a benefits, what we can have more even deeper insights compared to approach where we use just common information. It's a comprehensive understanding of customer behavior. We could gain an improved accuracy on, for example, churn prediction if we also analyze the customer feedbacks using large language models. And if we build our machine learning models using this combined approach, it's like, again, even more data-driven strategies for our business. And let me tell you about, for example, you already have a data. You believe that you are thinking about like, should you apply the machine learning, data science, or artificial intelligence in your business? Personally, I believe that even the smallest business who doesn't have a huge amount of data, in a couple of years will use artificial intelligence, machine learning, and data science because it is a must. But still, if we have a small scale operations in our business if we have a stable environment. But it sounds funny in our world, but okay, still imagine that we have a stable environment and we have a limited data, then maybe data science approaches and machine learning, we don't really need them right now, and just a common data analytical approach would suffice. But when we have more data, we already should consider machine learning. But now we should maybe decide, should we outsource the data science, the machine learning and artificial intelligence, or we should just hire data scientists, machine learning engineers, and have them in-house. Basically, it works like that. So when business lack the expertise, it is actually a common stuff. But if the business already have a data, the business should consider using machine learning. Yeah, and if business want to have the results pretty fast, and for not all the money in the world, it should also consider outsourcing. And outsourcing companies, they are mostly they are fast and they are flexible in their fees and their pricing in their terms, and they are pretty fast because they already have an infrastructure and expertise. But when your strategy or the strategy of your company is data driven, if your data is really complex and sensitive at the same time, and your company business model is all around continuous innovations, you should hire data scientists, machine learning engineers, and data engineers, and it will be really beneficial for you. But if you are this company, I believe you're already doing it. And yeah, that's it for today. Thank you. And maybe you have any questions, I will happily ask you. Sorry, I will happily answer questions.